Hey everybody, this is Larry. This is day 18 of the Leetcode Day Challenge. Hit the like button, hit the subscribe button, join me on Discord. Let me know what you think about today's problem. Today we have a hard problem, and which is a good time for me to yet one last time, because I think this weekend there'll be a lot of other things to do for me anyway. To spam DMOJ, which is our boy Josh, who is now actually not a boy anymore, but Anyway, he wrote a contest, yet another contest 9. I talked about it a bit the last couple of days. So I'm not going to talk more detail, but just support Josh, do the contest, have fun. I like the problems in general, like in the past, and it ends in 3 days, so you have the weekend to play around. Anyway, with all that said, let's go. Let's take a look at today's problem. We have 1368 minimum cost to make at least one routed path in the grid. Okay, so you have a grid, one means, okay, so you have something like this. You have to return the minimum cost to make the grid have at least one routed path. Okay, I mean, I think this may look like it's difficult, but which it can be if you don't have to write your right infrastructure in your mind or something, or your thinking process and all these things, right? The idea here is that okay, well, I mean, there are some things that are kind of like constraints that you are given this problem that may kind of look interesting. Like you can only modify the cell in the cell once, but you should not modify the sign on the cell more than once anyway on the shortest path. Because if you think about it in the example 1, or really any grid, what's the worst case? Well, the worst case is that, or just not even the worst case, but one case maybe, is that you just go all the way down and all the way to the right. Pretty straightforward, and that will cost you, at most R plus C time or R plus C minus 1, right? And of course, in that case, you only modify all the cell once. So that at least gives you an upper bound as to what to expect. But really, it just means that, well, if you go, you could think about this as changing the sign, that it costs 1 to change the sign. But you can also think about it as it's just a normal BFS problem. However, if you go on the signs that they tell you, it is free. And that really is, once you have the right idea and the right framing, then the programming, the implementation becomes much easier. Of course, this assumes you're well versed in shortest path problems. In this case, this is a queue-based shortest path problem, right? BFS, if you will. So yeah, let's get started on doing that then, right? I think I don't really have much to say about this one. So yeah, and then maybe like a distance. This you could do, right? Let's just say infinity times c, where infinity is just some big number, doesn't really matter what, right? And then now we want to include the beginning. We set the beginning to 0, right? We start at the upper left, right? Keeping in mind that, I think one thing that is possibly interesting if you haven't done similar problems before is that I know that's a shortest path and it's easy to associate path with how many steps you take or something, but there are other things. In this case is the shortest path where the thing is the cost, and the cost is your distance, right? So so there are things to kind of think about with that regard, and in this case, I think I skipped over it a little bit in terms of idea, and the reason why this can be BFSable is because all the distances and costs are 0 and 1, and so otherwise, maybe you have a variation on this problem. Maybe it goes, it costs 5 to change it to the right, 4 to change it down, or something like this. In that case, then you do need something like a Dijkstra's algorithm. But in this case, because you are only dealing with 0-1 costs, you can insert in the front or in the back in a 0-1 BFS. I don't honestly on these things. I've never done it as an interviewer, like on an interviewing side. So I don't know what the expectations about these things are, because it's just kind of like a little bit awkward in a sense, because I don't know that 0-1 BFS is like that widespread. So honestly, I'm not quite sure about, like do I need to do it this way versus just using a Dijkstra, which If I was an interviewer, honestly, I probably would have been okay with a dice drawer, but I also probably would just not ask these kind of problems. So like, that because I feel like these are okay. I mean, maybe I like I know I just do a BFS or dice drawers and that's it, right? Like I wouldn't ask this 0-1 BFS just because it just seems so awkward. But in any case, right? Oh yeah, and then you have directions is equal to right? Up, down, left, right. Not in that order, in some order, right? And then yeah. And then now what? Right? What am I doing? I'm honestly I don't know. I'm so tired this week. Right, and but these are just bound checking things. Though I keep saying that like, oh, it's just whatever, and I write the code and I end up making mistakes all the time. So I don't know. I feel like I've been very sloppy lately. But yeah. Okay, so new cost is equal to oh, what is grid? Okay, so grid 1 means cell can go to the right. So actually we should align this with the grid. So maybe you can even say maybe D for directions. And then now that just means that you have to do, okay, well, 1, 0 means that delta down. So this is actually a 3. Actually, they even tell you on the grid thing. So I think that's fine, right? So this is a 4. This is a 2. This is a 1, right? And then now, yeah, equal to, so NC is equal to 1 if grid of NX, oh wait, no, is it the current cell? Okay, yeah, if the current cells is equal to D, yeah, if the current cell is equal to D, then NC is equal to 0. Then now, yeah, if I mean, this is a breadth first search, so the first time you see it will be the best time. So if distances of nx and y is not equal to infinity, so the new cost thing, you can also write this as like greater than nc, but for BFS you should not need to if everything is right? Which sometimes it may not. But anyway, it's equal to NC and then Q dot append maybe. And I say maybe because this is where the 0, 1 comes into play, right? So if it's 0, we want to append left. Also, this is wrong. It's NC plus distances of XY, of course. And being silly today. Else, then we append to the right. And that should be good though. Though I feel like I've been making very sloppy mistakes lately, so who knows? Who knows? Yeah, there's a couple of ways you can do it. You can just write it like nx and y. And oh sorry, whoops. C minus 1 or minus 1. And there will always be an answer because as we said, in the worst case it'll just be r plus c minus 1 or whatever, right? Of course you have to make, I don't know how that happened, but that's okay. That's an easy fix. Huh. I mean, that means that something has gone wrong. Thanks, Larry, for letting us know. But, distance of xy. Huh. Why? Why is that? Let's see. Oh, well, it's just not going anywhere. txt. Oh, I'm dumb. This should be equal to, of course. I'm just really silly. I mean, it's still wrong, but at least, I don't know. Why is this 1? You got 0 to 2. It should be 0 do, right? Okay. Why did I put 1? Oh, this is 0 0. This should be 0. Append left. That is awkward actually. Don't know. Alright, let's see. Okay, so this is after one iteration. Wait, is it? Yeah. Oh, I'm wrong, huh? Okay, I'm wrong on this one. I guess I forgot about 0, 1 BFS. That's embarrassing. It's not the first time you for regular breadth first search. The first time you do it, it should be true, but in this case, it is not because it is a 0, 1 BFS. Am I doing that wrong? Huh? I guess so. But that means that this thing gets. No, but then the second time it just relaxed without adding more things. But man, why am I doing it wrong? Huh? I mean, even if this is right, I feel like there may be some like, yeah, I mean, that's fine. I'm not really worried about this part, but I am curious like whether my invariants are wrong in my head. Because you have to be willing to examine yourself, and even if you get it right, it doesn't mean that you'll get it right next time if your understanding is not clean, right? But what? Huh? I mean, I get that it goes down and then it just adds to the back instead, but and the second time it loops, even though technically speaking, we could do it so that it doesn't loop. But that second time will never add any more new nodes to the thing. Well, that's not true actually. No, yeah, because it's the second time you're parsing from the node, so it will not do it. But that is very awkward though. Am I thinking of something else? I mean, I think the other way I guess you could write this is that is that you can set it only when you relax, right? So maybe you could do something like this, right? Except for you don't update the distance, so then now update the distance here or something. But then now you have to append like the extra distance or something. It's very awkward. I don't know. Maybe I'm just being weird today. Maybe this is just the way to do it. But, I mean, and of course you have to do the thing that you kind of do. I mean, you don't have to, clearly. But you might want to do the thing that you do with Dijkstra, though in a grid case. I guess you only visit it at most 4. No, not even, because every time it has to be strict an improvement. So at most you visit each node twice. But the second time it won't even relax anything. It just does 4 operations, which is not ideal, but still not great. I don't know. I think that's all I have for this one, though. Let's call it a day. This is linear time, linear space, right? Because we look at each cell once. Well, I guess the way that I implemented maybe twice, but either way, yeah. And you have obviously O of n space here and in the queue, I suppose. And I say O of n, which is the size of the input, is because that is the number of cells, which is R times C. So n is equal to R times C in this case. So when you want to say linear, it is linear in the size of the input. So don't call it quadratic. Don't be sloppy. But yeah, that is all I have with this one, though. Let me know what you think. Yeah, thanks for watching. Hope your arrows turned out okay. That was not even good. Alright, thanks for watching. Stay good, stay healthy, to good mental health. I'll see y'all later and take care. Bye bye.